Hey guys, welcome to Technosart. This is Rohit Sharma, and in this video we are going to analyze a quiz 3 based upon analog electronics. I have divided three quizzes on analog electronics. One is I have taken on 12th of April, and for others I will inform you the dates in the Telegram group. Okay. Uh, in this quiz 3 we have total of 20 questions which contains 80 marks. Okay, and those who want to attend the quizzes. Attempt the quizzes, please join our Telegram group. It's Rota for EC fast as possible. Okay, so let's start the video. First is question number 1. Some 2-3 questions. I have given some theoretical questions. Okay, so see them. Okay, the concentration of minority carriers in an extrinsic semiconductor under equilibrium is inversely proportional, always inversely proportional to the doping concentration. Okay, if we increase the doping concentration, the concentration of minority carrier will decrease. If we decrease the doping concentration, the minority carrier's concentration will increase. Okay. Question number 2. Under low level injection assumption, the injected minority carrier current for an extrinsic semiconductor is essentially the diffusion current. Okay. Question number 3. The depletion region that is formed between P and N junction. Okay, we have positive negative ions on the other sides. Okay, some positive ions are there and some negative ions are there. Okay, option B is the correct answer. Question number 4. The junction capacitance of a PN junction depends upon both, that is doping concentration as well as the applied voltage. If we increase the doping concentration, the width of the depletion region will decrease. And if we increase the applied voltage, the width of the depletion region will increase. This is how the junction capacitance of PN junctions depend upon doping concentration as well as the applied voltage. Therefore, option C is the correct answer. Question number 5. A tunnel diode. This is a VSSC previous year question. Tunnel diode is a very highly doped PN junction diode. Okay. Option D is the correct answer. Option 5. A silicon P injection is followed by the constant current at room temperature. Okay, room temperature is always taken as 27 degrees Celsius. When the temperature is increased by 10 degrees Celsius, the forward bias voltage across the PN junction, we have to find the forward bias voltage. We know that dV by dt is given as minus 2.5 millivolt per degree Celsius. But he is talking about 10 degrees Celsius. So minus 2.5 into 10 will be 25 millivolt. Therefore, the forward bias voltage will decrease by 25 millivolt. Okay. Option D is the correct answer. Question number 7. Consider the following statement. Here we are talking about FET and we know the FET has high input impedance. Therefore, option 1 is correct. Compared to BGT, current flow due to the majority carriers. Okay. Low input impedance, this is wrong, and current flow due to minority carriers, this is also wrong. They have low output impedance, FET. Okay, therefore option 1 and 2 is correct. Therefore option D is the correct answer. Next question number 8. An n-channel JFET, that is IDSS, is given as 2 milliampere and VP is equal to minus 4 volt. Transconductance GM, we have to find the transconductance GM, which is given as, if you know the formula, GM is equal to GM naught 1 minus VGS upon VP. Okay. For this, first we have to find GM naught, and GM naught is given by minus 2 IDSS current upon VP. Minus 2 into IDSS is given as 2 milliampere, that is 2 into 10 to the power minus 3 upon VP. VP is the minus 4 volt. Okay. Minus plus 2 to the 4 will get cancelled with 4, 10 to the power minus 3. Okay. GM will be 10 to the power minus 3. I am putting the value in the formula for GM. 10 to the power minus 3 into 1 minus VGS is given as minus 2 volt in the question upon VP is minus 4. Minus 2 minus cancel. 2 upon 4 is 1 by 2. 1 minus 1 by 2 is 0.5. That is 0.5 milliampere per volt. Okay. Therefore, option B is the correct answer. Question number 5. As you all know, MOSFET can be used as a voltage controlled capacitor. Therefore, option B is the correct answer. Question number 10. the effective channel length of MOSFET in saturation decreases with increase in, with increase in drain voltage. How we can see this? If we increase VDS, that is the drain source voltage, when it will reach towards VD saturation, the inversion layer charge at the drain end becomes zero. The inversion layer charge will, at the drain end will become zero, and the channel will pinch off at the drain end. And when the VDS is greater than the VD saturation, when VDS is greater than VD saturation, then large portion of the channel is pinched off. Then large portion of the channel is pinch off, and the effective channel length is reduced. Effective channel length is reduced. What we have done is, firstly we have increased VDS up to VD saturation. We have seen the inversion layer charge at the drain end become zero, and some portion at the drain end of the channel is pinching off. When the VDS is greater than the VD saturation, then the large portion of the channel is pinched off. That is, the effective channel length is reduced. That is, drain voltage is the correct answer. Question number 11. When the gate to source voltage VGS of a MOSFET with threshold voltage, that is given as VT is equal to 400 millivolt, working in saturation, when it is in saturation, then VT is 900 millivolt. That is, VGS is equal to 900 millivolt. The drain current is observed to be 1 milliampere. Neglecting the channel width modulation effect, assuming that MOSFET is operating at saturation, the drain current, we have to find the drain current when applied VGS is 1400 millivolt. We have to find the drain current. If we know the formula for ID drain current, that is given by VGS minus VT whole square. VT is the threshold voltage here. From here I can find the value for K. VGS is given as 900 millivolt as it is in saturation, minus 400 millivolt square. K will come out to be 1 into 10 to the power minus 3, 25 into 10 to the power 4 into 10 to the power minus 6. This is minus 3. This will cancel out. We will get 10 to the power minus 3. This will equal to 1 upon 25 into 10 to the power 4 into 10 to the power minus 3. This will be the value for K. Now we have to find the drain current at when VGS is 1400 millivolt. K VGS minus VT whole square. K is given as 1 upon 25 into 10 to the power 4 into 10 to the power minus 3. VGS is 1400 millivolt given in the question. VT is 400 millivolt fixed. On solving this, we will get 4 milliampere as the correct answer for IT. Option C is the correct answer. Question number 12. The phenomena known as early effect in bipolar transistor refers to the reduction of effective base width caused by the reverse biasing of the base collector junction. This is a very important question. Please remember this. Early effect. If you want that I should make a video on early effect, what is early effect in BJT, then you should tell me in the comment section. I will make this video. Next question, question number 13. See this question. The 6 volt Zener diode shows in the figure has 0 Zener resistance, that is ZR is 0. And a knee current of 5 milliampere. That is the current flowing through the Zener diode is 5 milliampere. 6 volt is a Zener diode. The voltage across Zener diode is 6 volt. Therefore, this is 6 volt. Therefore, I can find the current flowing through this. That will be equal to I is equal to 10 minus 6 upon 50. 10 minus 6 is 4 upon 50. That will equal to 2 upon 25, which is equal to 80 milliamps. This will be here. I will be equal to 80 milliampere. 80 is going here, 5 is going here, 80 is going here, 5 is going here. What is the amount of current going here? 75. 75 milliampere. 75 plus 5 is 80 milliampere. Okay. Then 75 milliampere is going here. Then if we apply KCL in this, I can write 6 upon R, that is the voltage upon resistance, is equal to 75 milliampere. On solving, we can get the resistance, that is 6 upon 75 milliampere. Then I am shifting the milliamps to numerator, that will be 1000. Then 6000 upon 75 will be, it will come out to be 80 ohm. That is, the resistance value is 80 ohm here. Option B is the correct answer. Question number 14, very easy question. A diode is very useful for rectifier circuit. Due to its, we know that diode current flows only in one direction. Ability to conduct current only in one direction. Option A is the correct answer. This question is also very important. This is also VSSC previous year 2019 question. The built-in potential, we have to find the built-in potential here. Okay, and built-in potential is given as V0 is equal to Vt ln Na Nd upon में Ni square. ठीक है, here Vt is the thermal voltage, Na is the accepted density, Nd is the donor density, and Ni is the intrinsic concentration. Okay, so see this. For first case, they have said the V0. They have said V0 is 0.7 volt at room temperature. At room temperature, the thermal voltage is approximately is equal to 26 millivolt ln Na Nd upon Ni square. Okay. From here, I can find the value for ln Na Nd upon Ni square. That will be equal to 0.7 upon 26 millivolt. This will come out to be 26.92. 26.92. Okay, I am giving it as equation 1. Okay, what will be the approximate value of built-in potential if the doping concentration, that is the density, acceptor density and the donor density are double? Okay, then now equation will be Vt is 26 millivolt ln 2 Na 2 Nd upon Ni square. Okay, I am writing this as ln2 plus ln2. I am separating this by adding all these elements Na Nd Ni square. Okay, we know the value of La Na Nd upon Ni square is 26.92. Already find it. ln2 is given as the question, that is 0.7. 0.7 plus 0.7 plus 26.92 multiplied by 26 millivolt V0. On calculating this, we will get 0.7364 as the correct answer. That is the built-in potential of the diode. Option B is the correct answer. Okay. Now next question, question number 16. This is also very important question. In the given circuit, D1 and D2 are 5.1 and 6 volt respectively with forward voltage of 0.7 volt and the knee current flowing is 1 milliampere. Here you can see this is Zener diode. Okay. First of all, we know that Zener diode always work in reverse bias mode. Okay. Assuming D1 and D2 is not working. Okay. Then I can find the reference voltage, that is I can find the output voltage. Output voltage is given as minus Rf upon R1 into V1, as it is an inverting amplifier. Minus Rf is given by 2 minus 2 upon 1 into V1 is given as 5 volt in the equation. Okay, this will be equal to minus 10 volt. Okay, when V2 is minus 10, then and V1 V input is 5. Okay, V input is 5. Then if you see the circuit, D2 will be forward bias and D1 will be reverse bias. Okay, then the forward D2 will be forward bias and D1 will be reverse bias. Then the voltage across G2 will be 0.7 volt as it is forward bias and D1 is reverse bias, therefore the voltage across D1 is 5.1 volt. On applying KVL in this loop, we know according to op-amp, according to virtual theory, this potential is 0 volt. Now applying KVL, I will get 0 minus 0.7 minus 5.1 minus V output is equal to 0. Okay, from here I can find the output voltage, that will be equal to V output is equal to minus of 5.8 volt. Option B is the correct answer. These type of questions are very important as its ISRO point of view. Okay. Next question, question number 17. Let's see this question. A non-inverting amplifier with gain 10 is realized using an operational amplifier having open loop gain, that is AOL. Open loop gain is given as 10 to the power 5. Gain 10 is, that is closed loop gain is 10. We have to find the factor. Simply we are putting the formula. Closed loop gain is equal to open loop gain upon 1 plus beta open loop gain. Then 10 is equal to 10 to the power 5, 1 plus beta 10 to the power 5. By cross multiplying this, 10, 1 plus beta 10 to the power 5. 10 is equal to 10 to the power 5. 10 plus beta 10 to the power 6 is equal to 10 to the power 5. Now from here beta will be 10 to the power 5 minus 10 upon 10 to the power 6. On calculating this, we will get 99.99 into 10 to the power minus 3 will be the correct answer here. Therefore option A is the correct answer. This is the feedback factor beta here. Okay. Now question number 18. This is also very important. What is the operating region? For operating region of the transistor, we have to find the VCE, that is the quiescent point of this of BJT. Okay. From here I can find IB current. Can I write VCC minus VBE upon RB? VCC is 5 volt, VB is 0.7 volt, okay, and RB is 1. From here we can get 4.3 milliampere as IB, and we know that IC is equal to beta times of IB. Beta is given as 100 in the question. IB is 4.3 milliampere, that is 10 to the power 3, 10 to the power minus 3. We will get 0.43 ampere as IC. Now putting KVL in this loop, we are getting VCC is equal to ICRC plus VC, and we have to find VC. Therefore VCE is equal to VCC minus IC into RC. VCC is given as 5 volt minus IC is 0.43. We have find it right now. RC is 1K, that is 1000. Okay. On calculating this will get 5 minus 430. This will be equal to minus 425. And we know that when VCE is less than 0.2, then the transistor will be in saturation. But this is minus 425, and this amount is huge. Therefore, I can say this circuit is in deep saturation. Okay. Therefore, option D is the correct answer. Question number 19. This is also very important. In this circuit we have two op-amps. Okay, first is this, and second is a differentiator out of this. First, I am finding the output voltage here, that is V1. We can find here by implying superposition theorem in the op-amp circuit. Okay. Firstly, I am considering the inverting amplifier, then I will consider the non-inverting amplifier. On this, I can write V1 is equal to minus RF upon R1 into V1 plus, by considering non-inverting, 1 plus RF by R1, that will be equal to V2 into here we are applying voltage, that is the voltage dividing rule. We will get 10K upon 10 plus 10. Okay. Substituting the value, minus 10 upon 10 into V1 is 4 plus 1 plus 10 upon 10, V2 is 1, okay, into 10 upon 10 is 10 upon 20. Okay. On solving this will get cancelled. Minus 4 plus this will also get cancelled, plus 2 into 10 upon 20. 0, 0 cancel, 2, 2, 1, that will be equal to minus 3. Okay, minus 3 volt will be, V1 is equal to minus 3 volt. Now this is a differentiator circuit, and for differentiator circuit, we know that V0 is equal to minus R2C dV1 by dt. Okay, V1 is the output here, input here. Okay, and V1 is the constant, and the differentiation for constant is always 0. Therefore, V0 is also 0. Therefore, 0 volt is the answer. Option D is the correct answer. Last question. In the given op-amp circuit, find the current I0. This is the simplest question. I am applying nodal at this point. Okay. On applying nodal, I can write, and according to op-amp, this is zero potential according to virtual theory. Okay. That is V0. I am considering this as V0. V0 upon 100K plus V0 upon 25K plus I0, current flowing into the op-amp, is equal to, okay, by taking LCM here, 100K, we are getting as V0 plus 4V plus I0 is equal to 0. From here, I can write I0 is equal to minus 5V0 upon 100K. Now we have to find the value of V0. You can see this is an inverting amplifier, and for inverting amplifier, V0 is equal to minus RF by R1. These all formulas are for ideal cases into V1. Minus RF is 100. Minus RF is 100K upon 10K into V1 is 1. This will come out to be 10 volt minus 10 volt. I am substituting the value of V0 in the equation of I0. That is minus 5 into minus 10 upon 100 volt. 100K, okay, 100K, sorry, this is 100K. Minus 50, that will be plus 50, minus into minus plus 50 upon 100K. This will cancel out 0.5 milliampere is the correct answer. That is the I0. I0 is equal to 0.5 milliampere. Therefore, option B is the correct answer. I hope all your questions are solved for this quiz 3. And if you have any doubt, please ask me in the Telegram group or discuss with me in the Telegram group. And those who have not joined the Telegram group, please go and fast join the Telegram group. Okay, and please, if you like the video, share with your friend as much as possible, and please subscribe the channel so that you can get further updates of videos. Up to you. Okay, all the best. मिलते हैं next video में.